we're going to go ahead and get started on lesson 2, deploying Ethernet cabling, overviews, layouts for RJ45, so on and so forth. Let's move forward. At the physical layer, networks are made out of different types of cabling and their connectors and transceivers. These establish direct links between nodes and local segments. At the data link layer, nodes in these segments are given standard means of exchanging data as frames. Remember, we talked earlier in the first chapter about frames, data. So, as they're closely related, networking products often define standards for both physical and data link layers. Remember what we were saying before, your switches can be capped at certain speeds, your access points can be capped at certain amounts of devices that can be connected to them. While plenty of other products have been used in the past, many cable networks are now based on Ethernet standards. You guys won't see anything other than Cat5, Cat6, and moving forward, the newer type of standards that we have, fiber optics, so on and so forth. Understanding the options and specifications for Ethernet is essential to building and supporting networks of all sizes. In this topic, we will summarize standards for deploying Ethernet over copper and fiber optic media types and identify the tools and techniques required to deploy Ethernet cabling. So generally go over standards for Ethernet, copper cabling types, fiber optic, which is something new that you guys will be seeing, and we'll be deploying cabling ourselves and learning how to crimp, organize, and ensure that it works, and testing that.
The spiders showed us the truth.
Ethernet standards.
In Mordor cannot fall.
In this topic, we'll identify components used in Ethernet network implementation. Ethernet dominates the wired LAN product market. Its popularity is largely based on its ease of installation and upgradability. Large and small networks use Ethernet technology to provide both the backbone and end-user services. Due to a wide deployment of Ethernet today, you definitely will be required to manage and troubleshoot Ethernet networks as well as cables. Just like myself this morning, I had to redeploy the actual tip for the cable. Megan's desk was smashing the cable up against the wall, and unfortunately it damaged the port. So I had to replace the port itself, and luckily the previous technician that did the drop left an extra foot inside the wall, so I had enough space to be able to redeploy a tip. And always be courteous to your future technicians. Remember, we have a certain amount of space that we'll discuss on how far you can have between the tip itself and the shield of the cabling. And then we'll also discuss leaving a certain amount of cable in the wall after your drop or your remodel box to ensure that if there's any mishaps, any mess ups, or any feedbacks, you can redeploy that drop without having to rerun the entire cable, which was a definite help this morning.
Taking out the captain should buy the Gondorians some time.
All network signaling uses electromagnetic radiation of one type or another. Electromagnetic radiation means transmitting signals as electric current, infrared light, or radio waves. The electromagnetic radiation forms a carrier wave with a given bandwidth of range of frequencies. A signal is transmitted over the wave by modulation and encoding schemes. One example of encoding is transitioning between low and high voltage states in an electrical circuit, making use of a characteristic we call wave amplitude. That's still here. Okay, good. These voltage changes can encode digital information, ones and zeros or bits, and we talked about that as far as hexadecimal bits, so on and so forth previously. The more bandwidth available in the media, the greater amount of data that can be encoded. And that's something that we'll hopefully visit later, bandwidth versus speed, because there are certain internet connections that will prefer bandwidth over speed. And you'll have to distinguish the differences for those, like T1, T2 connections, and other types of connections like those. Copper cable. You guys will be familiar with this once you see it here in a bit. Twisted pair. Copper cable is used to transmit electrical signals. The cable between two nodes creates a low voltage electrical circuit between the interfaces and the nodes. There are two main types of connectors for a copper cable: the twisted pair and the coaxial. Nowadays, in most situations, especially in our state, you'll be seeing the coaxial copper connection. Copper cable suffers from high attuition, meaning that the signal quickly loses strength over long links. Twisted pair cable is related to CAT standards. And that's why a lot of the times when you have Comcast or Xfinity Link come in and install a cable, they try to immediately get that cable in from the house and have the shortest distance between the modem and the cable they drop into your house. Fiber optic cable, that's something that's a newer standard that's been being released to residential clients as we see throughout the next coming months. Rio Rancho is getting fiber optic currently with Comcast. Fiber optic cable carries very high frequency radiation in the infrared light part of the electromagnetic spectrum. The light signals are also not susceptible to interference or noise from other sources and less affected by attuition. Consequently, fiber optic cable supports a higher bandwidth over longer links than copper cable. And that's why people are preferring it, but since it's so new, it's a lot more costly. Fiber optic cabling is divided into single mode, SMF, and multi-mode, MMF. And the MMF is categorized by optic mode designations, usually OM1 and OM2, OM3, OM4. Ethernet standards. Over the years, many protocol standards and products have been developed to implement the functions of physical and data link layers of the OSI model. Remember those layers from the first chapter, the 7 layers that we go from physical all the way up to the last layer. Okay, the most important of these are the IEE standards, the Institute of Electrical and Electronics Engineers 802.3 Ethernet standards. And something that you guys will have to remember about this is this sometimes varies between state. When we did the Bellagio network in Vegas, this was God. That was a whole different lifetime years ago. We were required to run conduit in anything that we did low level voltage. In the state of New Mexico, you're not required to run conduit. So always make sure that you refer to standards and compliance measures per state that you're in. And sometimes it's required per city or county. So you have to be extremely careful when you're doing deployments like this. Ethernet standards provide assurance and network cabling will meet the bandwidth requirements of the application. The standards specify bit rate that should be achieved over different types of media up to supported distance limitations. These Ethernet media specifications are named using 3-part conventions, which is usually referred to X base Y. This describes the bit rate in megabits per second or gigabits per second, the signal mode, baseband or broadband, you'll hear that very common. All mainstream types of Ethernet use baseband transmission, so you will see specifications of the form of X base minus Y. A designator for media type. For example, 10 base T denotes an early implementation that works at 10 megabits per second. It uses baseband signal and runs over twisted copper cabling, a T connection. Not a T1, just a standard T.
It doesn't look good for the
Media access control and collision domains. Ethernet is a multiple access area network, which means that the available communications capacity is shared between the nodes that are connected to the same media. Media access control, MAC, refers to the method a network technology uses to determine when nodes can communicate on shared media and to deal with possible problems, such as 2 devices attempting to communicate simultaneously. Ethernet uses a contention-based MAC system. Each network node connected to the same media is in the same collision domain. When 2 nodes transmit at the same time, the signals are said to collide and neither signal can reach its destination. This means that they must be resent, reducing available bandwidth. The collisions become more frequent as nodes are added, and consequently, the effective data rate is reduced. Another type of collision that you guys will experience as well is the IP conflict issue. And that's why a lot of times most people will have to set that static IP we were discussing yesterday in your adapter settings. When you have IP conflict issues, you'll see two systems that won't connect to the internet, and sometimes those systems, it'll be an Alexa dot device or an Echo device. It can be a computer conflicting with another user's cell phone device. It could be a lot of things that are causing IP conflict issues. And later on, you'll learn how to determine, looking through either a trace route or a command prompt PowerShell, or even tools like Advanced IP Scanner to see what's out on the network and what is assigned what IP. Okay, so the Ethernet protocol governing contention and media access is called the carrier center. It's called the carrier sense multiple access with collision detection, CSMA-CD. You'll hear this a lot in Comcast Business, or as well as any business ISPs that you deal with. A collision rate is the state when the signal is present on the interface's transmit and receive lines simultaneously. On detecting a collision, the node broadcasts a jam signal. Each node that was attempting to use the media then awaits for a random period that backs off, basically, like a dam, open, shut, before attempting to transmit again. And of course, you guys see an example here, data to transmit, check the network, and ensure that there's transmittable data, and there's a preamble. If there's a collision, it decides to wait and then retransmit the data when there's no other data being transmitted. Awesome. The collision detection mechanism means that only half duplex transmission is possible. This means that a node can transmit or receive, but it cannot do both at the same time. In the base 10T wiring topology, each node is cabled to an Ethernet hub, and the hub repeats incoming signals to each connected node. Consequently, each host connected to the same hub is within the same collision domain. And the 10 base T standards from 1990, you are very unlikely to find it deployed on any networks. You're usually going to deal with 100 base or 1,000 base nowadays. Moving on to 100 base.
Subtitles for everybody.
I think most days. Have you seen anything that's less than a gig, Bob, lately? I think it's a gig lately, right?
For what?
For any standards like that come on a board or any controller nowadays.
Well, yeah, gig is what we're actually going to push as the normal standard.
Yeah.
But
yeah, I hardly ever see any controllers or anything with 100 base or 10 base anymore.
I can show you one.
Yeah, I definitely have some at the shop, and I'm getting the team down there to get me some, things I can display and show to the students. But of course, something like this, we're gonna have to go back to XP systems.
Yeah.
Okay, so we have the 100 base TX fast Ethernet standard. The fast Ethernet standard uses the same CSMA-CD protocol as 10 base T, but with higher frequency signaling and improved encoding methods, raising the bit rate from 10 megabits per second to 100 megabits per second. 100 base TX refers to fast Ethernet working over Cat5 or better, Cat5e, Cat6, so on and so forth. Twisted pair copper cable with a maximum supported length of 100 meters, 328 feet. So you have to remember that if you're running 100 base TX cable that's Cat5, you can go a maximum of 328 feet. That doesn't mean 328 feet and then, the connection and the drop, that's literally 328 feet, because then you're going to experience packet drops. 100 base 10 TX can be implemented with a hub, but most networks started to replace hubs with switches as a connection point for end systems. The contention-based access method used by hub does not scale to a large number of systems with the same collision domain. Where a hub works only at the physical layer. A switch uses information about the source and destination addresses carried in the layer, 2 frames, to establish a temporary circuit between 2 nodes. Unlike a hub, each switch port is a separate collision domain. By eliminating the effect of contention, switches allow for full duplex transmission, so you're not cut to half duplex. And remember that standard terminology just means that you're either going to be running at full speed or half speed. where a node can transmit and receive simultaneously, and each node can use the full 100 megabits per second of the bandwidth for the cable to link to the switch port. To support compatibility with hosts still equipped with 10 megabits per second Ethernet interfaces, Fast Ethernet introduced an auto negotiation protocol to allow a host to choose the highest connected connection parameters, 10 or 100 megabits per second, and half or full duplex. 10 base 10 Ethernet specifies a node should transmit regular electrical pulses when it is not transmitting data to confirm the viability of the link. Fast Ethernet codes 16-bit data packets into the signal, advertising its service capabilities. This is called a fast link pulse. Remember that, a 16-bit data packet into the signal to advertise its service capabilities is a fast link pulse. A node that does not support auto negotiation can be detected by one that does and is sent ordinary link integrity test signals or normal link pulses. Fast Ethernet would not be deployed on new networks, but you may need to maintain it in legacy installations. And if you guys recall that this is going to be showing you guys yesterday, give us a moment, the network adapter settings.
Did Jonathan have a question? Had his hand up earlier.
What's up, Jonathan?
It hasn't looked good for weeks.
He had his hand up, but you were going at it, so like.
So usually in here, guys, in your controller settings that you'll find in your wireless properties, control settings. If you ever have a legacy installation, you have a newer switch, you can actually set bandwidth values in your settings here itself as well. There's different settings that you can take care of that, especially for Ethernet ports, which this won't show you it. No, that's my USB.
Yeah, go boy, but I need you to get down. We've lost the middle city. Get down. Rally at the gate. Keep moving. We'll cover your retreat. Go boy.
See RX and TX enabled. And you can even edit in here IPv4 check offload, checksum offload, and we'll hopefully discuss that later in VLAN IDs. Just in case you guys ever run into a situation that you need to set those settings in the adapter for a computer itself. No question, Jonathan?
The middle city is lost.
I was trying to make sure he got his codes, and I was looking to see if they were given to me or given to you.
Let me see.
Oh, gotta go to the tab. It tells me the right tab first.
While you look for those, I'll move forward.
Okay.
And then let me know if you don't find them, and I'll check my email.
Okay.
Gigabit Ethernet standards, guys. Gigabit Ethernet builds on the standards defined for Ethernet and Fast Ethernet to implement rates of 1,000 megabits per second, a gigabit. That's right, everybody wants that gigabit speed. Usually nowadays, we can end up getting 300 gigabits depending on the service we choose. Okay. Over copper wire, Ethernet, Gigabit Ethernet is specified as 1,000 base T, working over Cat5e or better. So remember, if you have Cat5, you're not going to get that full speed of 1,000 megabits per second, gigabit. Gigabit Ethernet does not support hubs. It is implemented only using switches. And nowadays, you guys won't find hubs unless you're dealing with small businesses. I still myself find hubs and old lawyers' offices and stuff like that. The maximum distance of 100 meters, 328 feet, applies to cabling between the node and the switch port, or between two switch ports. So you can go 328 to one switch and then 328 to another switch. Gigabit Ethernet is mainstream choice for new installations of access networks. That is, cabling to connect client workstations to a local network. So, for instance, a computer to a server, a computer to your file server where you're hosting a Plex server. Any of those examples would work. The main decision would be whether to use copper or fiber optic cable once you get to these speeds. Fiber gives a better upgrade potential in the future, while copper cable is still cheaper to install, and far more hosts are installed with network cards that support copper rather than fiber. And then you still have the ability to run fiber just for the business and then convert over to a standard switch. And hopefully we discuss that here soon. If not, I'll give you guys some study material that you can look into that. 10 gigabit Ethernet, 10 GBE multiplies the normal speed of gigabit Ethernet by a factor of 10 because of the higher frequencies required. 10 gigabit Ethernet can only run at reduced distances over unshielded twisted pair. Longer runs require higher categories of cable with some type of shielding. These are also specifications for 40 gigabit 40 gigabits Ethernet.
Cannot match the orcs for their numbers or
See if it looks
ferocity.
like it shows you the specification. It does not.
But some things were lost forever.
Yes.
You guys don't have the book with you. You'll see there. This is when we start seeing that new cat.
Go to the Great Hall.
Cat 8.
Secure the
A lot of
ramps.
people don't really use Cat 8
My place
unless you have
is
to do
here.
Make sure
some extreme speeds there.
Is that an order?
And as you can see, as you progress, you get into Cat 8.
We must protect
It drops.
what is most precious
At all costs.
Yes.
And I'll upload that to you guys. Screenshot.
done.
Give me a second.
But I'll be back on the wall before the next assault.
Snipping tool. Where's the chat? Yeah, usually Wall Street, high data centers will use connections like this. And I've seen even companies like UPN, United Private Networks, we partner with them and we deploy their networks. I'm still hearing back from Glenn if we can do a tour of their facility where we deployed fiber optic with United Private Networks, and those speeds that we were getting were up to 900 gigabits per second. I mean, I still go to their parking lot and I connect to their Wi-Fi if I ever need to download a movie and it like that. So, and that's the Carlisle Executive Building right across the street from Wiener Schnitzel on Carlisle in Albuquerque. But once I hear back from them, we might be able to take a class trip to take a look at that. Moving forward. 1040 GBE, gigabit Ethernet, is not deployed in many access networks. Oh, I saw someone typing. Yeah, it'd be awesome. I'll let you guys know about that. There's a couple clients I'll be connecting with to see if we can go do a tour of a couple of their facilities.
The city is weak, and it will not
okay.
hold for much longer.
1040 gigabit Ethernet is not deployed in many access networks. The cost of 1040 gigabit Ethernet compatible network adapters and switch transceivers modules is high. It might be used where a company's business requires very high bandwidth data transfer, such as TV and film production. We work with a lot of cultivation facilities that work with the Department of Agriculture and the New Mexico Regulatory Licensing Division. That's part of a certain industry that I'll leave unsaid. But these companies, like HDR, they require faster fiber optic connections. And it became costly because, of course, Comcast provides you with a fiber optic switch, but you have to get a layer 3 switch to be able to convert the fiber optic to a standard addressable IP address. And that layer 3 switch is the actual switch that spits out the IPs, not the fiber optic switch. The fiber optic switch gets an assigned static IP, which then assigns, all the standard IPs internally in the network. And that's another place that I'll also ask as well.
Sauron's low craft against him.
These towers can give us sight.
We will purify them. And make them ours.
All right, everybody. We're going to start on topic 2B. Summarize copper cabling types. Already off to a good start. Copper wire twisted pair cabling is the most popular choice for access networks and offices. You are likely to work with this network media daily as a part of your duties as a network professional. Understanding the characteristics of twisted pair will enable you to properly install and service your networks. Twisted pair is a type of copper cable that has been extensively used for telephone systems and data networks. One pair of insulated wires twisted together forms a balanced pair. The pair carry the same signal, but with different polarity. One wire is positive and the other wire is negative. This allows the receiver to distinguish the signal from any noise more strongly. The cable is completed with an insulating outer jacket as well. And of course, you guys see an example of that. A twisted pair cable, you see each is color-coded and twisted at a different rate to reduce interference. Now this is what you're going to see normally when you do an RJ45 connection or an Ethernet jack, whether it's to do 568A or 568B connections. The pairs are twisted at different rates to reduce external interference and crosstalk. Highlight this next sentence. Crosstalk is a phenomenon whereby one pair causes interference in another as a result of their proximity. Twisted pair can use either solid or stranded conductor wires. Highlight this sentence as well. Solid cabling uses a single thick wire per conductor and is used for cables that run behind walls or through ducts. Highlight this sentence. Stranded cabling uses thin filament wires wrapped around one or another and is used to make flexible patch cords for connecting computers to wall ports and switches to patch panel ports. Copper wire thickness is measured using the American wire gauge. Increasing AWG numbers represents thinner wire. Highlight this part. Solid cable uses thicker 22 to 24 AWG, while stranded cable used for patch cords is often 26. The attenuation of stranded wire is higher than solid wire, so it cannot be used over extended distances. Most twisted pair cable used in office networks is unshielded pair
This one was trying to
twisted
be
pair,
subtle.
UTP.
One of Mordor's
Modern
assassins.
buildings are often
There will be
flooded
others.
or using UTP cabling. This involves cables being laid to every location in the building that may need to support a telephone or computer. Shielded and screened twisted pair cable. Shielded cable is less susceptible to interference and crosstalk. This type of cable is required for some Ethernet standards and may also be a requirement in environments with high levels of interference. Highlight that last sentence. Shielded cable can be referred to generally as shielded twisted pair, STP, but there are several types of shielding. Screened cable has one thin outer foil shielded around all pairs. Highlight that. Screen cable is usually designated as screened twisted pair, SCTP, or foiled unshielded twisted pair, FUTP, or sometimes just foiled twisted pair, FTP. Highlight this next sentence. Fully shielded cabling has a braided outer screen and foil shielded pairs, and it is referred to as shielded foiled twisted pair, SFTP. There are also variants with foil outer shield, FFTP. Legacy STP cable could be complex to install as it required bonding each element to the ground manually. But modern FUTP and SFTP solutions use the appropriate cable, connectors, and patch panels. This reduces the complexity, and highlight this, by incorporating bonding within the design of each element. Now there's a little subnote in your book underneath that. Highlight that as well, because that will be in your exam. Using screened or shielded cable means that you must also use screened shielded connectors. Screened shielded cable elements should not be mixed with unscreened unshielded elements. It's a big no-no. You'll experience issues. CAT cable standards. The American National Standards Institute, ANSI, and the Telecommunications Institute Association, TIA, Electronic Industries Alliance, EIA, have created categories of cable standards for twisted pair to simplify selection of a suitable quality cable. Now, I want you guys to highlight that first sentence because you will have some questions in there. And it's just going to be generally who is responsible for these standards, what are the organizations that define what these cables should be built and running as. These categories, along with other aspects of telecommunications wiring best practices, are defined in the ANSI TIA EIA 568 Commercial Building Telecommunications Cabling Standards. And you guys see a link for that there in your book. Similar standards are also maintained by the ISO, which refers to categories of components and classes of permanent links, incorporating both cable and termination. And that's where Mr. Hobbs is going to go work here soon. And of course, there you see a chart in your book of what you have for your standards. And what I'm going to do is I'm going to copy that. I'm going to send it to you guys. And if I don't copy it and send it to you and continue, please just go ahead and take a screenshot and save it for yourselves. Because you can see there that Cat3 is a UTP cable, the speed and the network application it's used for. Its max distance, remember they're working with meters, but they do put in parentheses in feet for us. And its frequency that it's running at. And of course the type of connector that you need to use. And you don't start seeing shielded connectors until you get to Cat 7, all the way up to Cat 8.2. For 1000 base T, Cat 5 is also acceptable, if properly installed. But Cat 5 cable is no longer available commercially. Unlike Ethernet and Fast Ethernet, Gigabit Ethernet uses all 4 pairs for transmission, and thus is more sensitive to crosstalk between the wire pairs. Here are some details about the categories used for network media. Cat 5 is no longer available. Cat 5e is tested at frequencies up to 100 MHz, like Cat 5 was, but to a higher overall specification for attenuation and crosstalk, meaning that the cable is rated to handle gigabit Ethernet throughput. Cat 5e would still be acceptable choice for providing networking for workstations. Cat 6 can support up to 10 gigabits, but over shorter distances, nominally 55 meters, but often less if cables are closely bundled together. Cat 6a is improved over Cat 6, that it can support 10 gigabits over 100 meters. Cat 6a cable is bulkier than Cat 5e, and the installation requirements are more stringent, so fitting it within pathways designed for an older cable can be problematic. TIA and EIA standards recommend that Cat 6a is recommended for use in healthcare facilities. With power over Ethernet PoE 802.3bt installations and for horizontal connections to wireless access points. Cat 6 cable is always of a screen shielded type and is rated for 10 gigabit Ethernet applications up to 100 meters or 328 feet. Cat 7 is not recognized by TIA or EIA, but appears in the cable standards created by ISO. Remember this part and highlight it. It must be terminated with G45 or Terra connectors rather than standard RJ45 connectors. And you see that in that chart that I sent you as well, or that's in your book. Cabling is not the only part of the wiring system that must be rated to the appropriate category. For faster network applications, gigabit, Ethernet, and better, the performance of the connectors becomes increasingly critical. For example, if you're installing a Cat 6a cable, you must also install Cat 6a patch panels, wall plates, and connectors. Excuse that, sorry about that, guys. Cat 6 is intended for use in data centers, only for short patch cable runs that make top-of-the-rack connections between adjacent applications. ISO defined 2 variants. 8.1 Class 1 is equivalent to TIA EIA standards. Cat 8, and uses RJ45 connectors, while 8.2 Class 2 must use outer shielding or screening and GG45 or Terra connectors. Twisted pair connector types. Twisted pair copper cabling uses registered jack RJ connectors or the physical interface. There are many different types of RJ connectors, identified by numbers and sometimes letters. Some are physically different while others are identical but wired differently for different applications.
Nothing can hurt me.
RJ45 connectors are usually with 4-pair 8-wire cables. The connectors are also referred to as 8P8C, standing for 8 positive, 8 contacts. This means that all 8 potential wire positions are supplied with contacts so that they can all carry signals if needed. RJ45 is used for Ethernet twisted pair cabling. Of course, you guys see an example of this guy here. RJ11. You'll be familiar with RJ11 if you're used to old phone landlines. RJ11 is small, and the connectors are used with 2 or 3 pair UTP. Highlight that first sentence. There is room for 6 wires, but the 4 center wires are the most commonly used. Typically, the innermost pair, wired to pins 3 and 4, carries a dial tone and voice circuit. These are also called the tip and ring wires, after the way older phones were wired. The other pair is usually unused, but can be deployed for a secondary circuit. RJ11 connectors are used for telephone systems, for example, to connect a modem to a phone jack. They're also used for cash registers too. Highlight this one part here. An RJ11 connector only has 2 contacts, 6P2C. To use more pairs, the jack can be wired as RJ14, 6P4C, or RJ25, 6P6C. Copper termination standards. Each conductor in a 4-pair cable is color-coded. Each pair is assigned a color: blue, orange, green, or brown. The first conductor in each pair has a predominantly white insulator, with strips of the color. The second conductor has an insulator with a solid color. The ANSI-TIA 568 standard defines 2 methods for terminating Ethernet connectors: T568A and T568B. The wiring for both standards is shown in the following figure. You guys can see that there. And you see the difference as it alternates.
All that
These
armor
2.
makes my task more difficult.
And most of the time, you'll usually
combat
find
to
a
exhaust us.
568 standard.
Doomed.
Some people use the 568A standard. In the 568A, the green pairs are wired to pins 1 and 2, and the orange pins are wired to pins 3 and 6. In the 568A, these pairs swap places, so the orange is terminated to pins 1 and 2, and green to 3 and 6. Organizations should try to avoid using a mixture of the 2 standards. T568A is mandated by the US government and should be the residential cable standard, TI 570. But T56B is probably more widely deployed of the 2. And of course, you guys see there a chart of everything that you need. Pin 1, what it's responsible, transmission, positive, transmission, negative for orange. Of course, you see there stripy orange, white, receive, positive. We got 4 for blue, and it continues there. Plenum and riser related to cable. Basic cable consideration decisions include the category unshielded versus shielded, and the appropriate use of solid versus stranded cable. Another consideration is how cable installation must conform to any national or local building regulations. Highlight this sentence. A plenum space is a void in a building designed to carry heating, ventilation, and air conditioning, HVAC systems. Plenum space is typically a false ceiling, though it could be constructed as a raised floor or a crawl space. As it makes installation simpler, this space has been also used for telecommunications wiring. In some building designs, plenum space is an effective conduit for fire. as there is plenty of airflow and no fire breaks such as walls or doors. If the plenum space is used for heating, there may also be higher temperatures. Therefore, building regulations require to use fire retardant plenum cable in such spaces. Plenum cable must not emit large amounts of smoke when burned, be self-extinguishing, and meet other strict fire safety standards. General purpose non-plenum cabling uses PVC jackets and insulation. Plenum rated cable uses treated PVC or fluorinated ethylene polymer (FEP). This can make the cable less flexible but more susceptible to, let's say, if there's a fire, it would put itself out. You need to make sure that you guys use these cables when you guys run anything, whether it's in a crawl space, an attic space, anywhere. Unless it's just going from the wall to the workstation, plenum cable should be used. Say for instance you have to run in our building, there's no real runs for our cable all the way to the back in the garage. So we have to use plenum cable in our HVAC system because it's responsible for heating and cooling. That way if there ever is a fire, it puts itself out and extinguishes itself. General purpose non-plenum, okay, my apologies, I already read that. Let's see, data cable that is plenum related under the U.S. National Electrical Code is marked CMP, MMP. General purpose cables are marked with CMG or MMP or CMMP. Highlight that because you guys will actually learn to look at your cables, especially because it's also good to learn how much cable you have left. For instance, if you have to run 100 feet, you can look at your actual cable to tell you how much feet are left on the spindle. Cabling that passes between two floors is referred to as a riser. Conduit for the riser cabling must be fire stop. Highlight those last two sentences. This means that the fire cannot spread through the opening created by the conduit. Riser cabling in conduit or in spaces such as a lift shaft should also conform to the appropriate fire safety standards. These are similar to the requirements for plenum spaces, but not quite as strict. Highlight this part. Data cable that is a riser rated under the NSC is marked CMR NPR. So the same goes for anything between two floors. You have to use a specific cable. Coaxial and twin coaxial cable and connectors. Highlight this part. Coaxial, otherwise known as coax, cable is made of two conductors that share the same axis, hence the name co and ax. The core conductor of the cable is made of copper wire, solid or stranded, and is enclosed by plastic insulation. A wire mesh, the second conductor, which serves both as shielding from EMI and as a ground, surrounds the insulated material. A tough plastic sheet protects the cable. Of course, you guys see an example of that in your book. Coaxial cables are categorized using the radio grade standard, which represents the thickness of the core conductor and the cable's characteristics impedance. RG6 is 18 og cable with a 75 ohm impedance, typically used as drop cable for cable access TV, CATV, and broadband cable modems. For this application, coax is usually terminated, and highlight this part, using F-type connectors, which are screwed into place and secured. You guys can see that cable there. You guys are familiar with the old school Nintendo, Super Nintendos, things like that. I'm sure you've had to replace these a lot of times. Twin axle. Twin axle or twin ax is similar to coax, but contains two inner conductors. Highlight that part. Twin ax is used for data center 10 gigabit Ethernet, unofficially referred to as 10G base CR, and 40 gigabit E, referred to as 40 gigabit base CR4, interconnects of up to 5 meters for passive cable types and 10 meters for active cable types. Highlight this next sentence. Twin ax or 10 or 40 gigabit Ethernet is terminated using SFP plus direct attached cable, DAC, and USFP plus DAC transceivers. And when you guys are dealing with this, you have to remember, like for instance, we work with Comcast Business. We're Comcast Business affiliated at Daedalus Teks. We, we make money for selling fiber optic. We would rather sell fiber optic, and in those instances, when you have a fiber optic connection coming in from your DMARC, a lot of individuals say, oh, I bought the fiber optic, but my Comcast technician told me that I have to purchase my own switch. And yes, you need a layer 3 switch. You need a layer 3 switch with an SFP module or a QSFP module to be able to handle that IP assignment, right? Because your fiber optic switch will not assign and dedicate IPs. We'll discuss that in later lessons, but in that instance, you actually have to find a switch, and most switches that have those modules are expensive, and in some cases, like with us, we partner with Unify, and Unify actually offers those small little add-on modules that you can slide into the switch, and boom, you're all set. That is correct, David. Yes. It only works at the layer 2, which is why you go from your layer 3, get a layer 2 switch, which then assigns all the IPs, and then you can assign that to all your computers. So we're at the end now, and what we're going to do is stop the recording and start our review.
In this video, we'd like to discuss some of the guidelines for installing bounded network media. One of the first things that you want to do is make sure that you are following the 568 Commercial Building Telecommunications Cable Wiring Standard. It is important, just like we've seen in other demos, you want to make sure when you're wiring things like your Ethernet cables, not all the way following the structured wiring, but what cable types are we using? Are we using Ethernet cables? We are using Ethernet cables, which is probably what you're going to be using because it's the most dominant LAN communication technology. Are you going to be using copper-based media? Are you going to be using fiber-based media? It's important to make these decisions. Create a list of those requirements, and if you need something like maybe a 10G network, we're going to go with something like multi-mode fiber. We make sure that we have our standards present. If it's 10G base SR, that we are following those standards. It is important that you consider the factors that can affect the performance of your network. For instance, if you have electromagnetic interference, if you've got fluorescent lighting within your network area, if you will, that can have an adverse effect on performance levels. The other thing to keep in mind too is that not only do we have electromagnetic interference, it's also that we have to worry about things like signal attenuation. So we got to take into consideration those things that have an adverse effect on the cabling, even if we're following all of the standards. So also consider things like some of the environmental limitations. For instance, your HAVEX systems. It's important to make sure that you have a climate-controlled system within your server closets. Remember that as you add more devices, the heat is definitely going to start to rise. The temperature, I should say, is going to start to rise inside of those server closets, and you don't want to put a new device in there, have it raise the temperature of your server closet, and start causing thermal shutdowns and thermal failures across the devices within that server closet. The other thing you have to keep in mind, too, think about plenum spaces, right? Your air handling spaces. It's important in the plenum spaces that you're using plenum-grade wiring for fire codes, building codes, if you will, fire codes more specifically. And in those non-plenum spaces, you can use non-plenum. Keep in mind that this is typically clearly labeled on the outside of the box that, for instance, your Ethernet cables come in, and it's important to make sure that you are you're complying with whatever your fire code is, and that we're not running something that has a polyvinyl chloride jacket around it because of the dangers that it presents. The other thing, too, is not only do we want the heating or the ventilation system inside of our server closets to be adequate to cool the systems, we also have to keep in mind things like cable management. We don't just want to haphazardly throw our equipment inside of a physical barrier, which we should be doing, so nobody can gain access unless they're authorized to be in that area. We want to use like a rack system. It is important to use a rack system, and what this helps us to do is it helps us to maximize how we use the space within inside of the server closet or your telecommunication closet, wiring closet, all synonymous terms. It's also important to make sure that not only are you employing a rack system, you're also employing good cable management systems, and this will be something such as your cable trays, cable baskets, if you will. Sometimes I've seen zip ties that you can do in order to make sure that those cables are not just loosely thrown in there, and it's also good for when you're diagnosing issues that you can follow cables a little bit easier. And again, just make sure that you have good cable management system in place. Another thing too is to make sure that you have the right cables. Remember that if you're using a multi-mode fiber solution, we're not going to be connecting that with outside of some kind of converter. We're not going to be connecting that to a copper-based media. So that is important. Remember, too short of a cable, you can pull on the connectors. It can damage the cables as well. The other thing too is proper labeling of your devices, and this really helps out, especially when you're trying to locate a specific device, identify a problem that might be going on. You can get to that device a lot easier if you have good labeling. The other thing too, along with good labeling, I might say, is good documentation too. And one of the things that can happen over time is as you move devices around, as you change and readjust the location of the cables within your patch panel, a lot of times you can have loose wires and unused wires, and these can start to accumulate a lot to where you've got a lot of loose ends within your server closet. So we want to make sure that we remove those unused cables just to make it neater, but it also prevents somebody from taking a device and going into your server closet and patching down and potentially getting unauthorized access. These are some of the guidelines you should keep in mind when you are installing bounded network media.
We're going to move on to discussing fiber optic cabling types. This is just a general summary. Fiber optic media can support higher bandwidths over longer distances than copper wire. The advantages make it a popular choice for long-distance telecommunication networks and for reliable, high-speed networking within data centers. Understanding the characteristics of fiber optic media will help you to understand, support, and troubleshoot existing installations, as well as provide upgrades. Fiber optic cable considerations. The electrical signals carried over copper wire are subject to interference and attenuation. Fiber optic signaling uses pulses of infrared light, which are not susceptible to interference, cannot easily be intercepted, and suffer less from intuition. Consequently, fiber optic cabling supports higher bandwidth over longer cable runs that can be measured in kilometers rather than meters. That's right, kilometers. A single optic fiber is constructed from 3 elements. Core provides transmission path for light signals, waveguide, otherwise known as. Cladding reflects signals back into the waveguide as efficiently as possible, so that the light signal travels along the waveguide by multiple internal reflections. The core and the cladding can be made from a glass or plastic. Cladding is applied as a thin layer surrounding the core, while made of the same material. The cladding has a different refractive index to the core. The effect of this is to create a boundary that causes the light to bounce back into the core, facilitating the process of total internal reflection that guides the light signal through the core.
You're out there.
The buffer is a protective plastic coating. It may be of tight or loose configuration with a loose format using some form of lubricant between the strand and the sheet. In basic operations, each fiber optic strand can only transit light in a single direction at a time. Therefore, multiple fibers are often